Hi guys, in this particular video I'm going to be focusing on competitive inhibition. Now this topic is quite easy. I just need you guys to follow me very carefully so that no one gets lost. Alright, now I'm having E plus S gives reversible reaction, let's not forget that, ES, okay, and I also know that ES will break down with K2 here, giving me E plus P. Now this reaction here, that's the K2 K1, can be sometimes collectively known as KS. Okay, now let's notice something, or this can be called KM also. This is also known as KM. That's the Michaelis constant. It's also, it could be called KS or KM depending on whichever you want. Now let's focus on something. Now what does competitive inhibition means? Now it's very easy. What happens is that, let's say I have an enzyme, okay, and I have a substrate. My substrate is like this. You agree with me that, sorry, the shape might not be looking so good. If this enzyme and substrate, this is my enzyme and this is my substrate, if they react together, they fit it into each other perfectly to form a complex. Then my complex can further break down into my product and my enzyme. Good. Now in some cases enzymes could react with substances known as inhibitors. Okay, now what would these inhibitors do? This spot here is known as the active site of this enzyme. This spot here, okay, is known as the active site of the enzyme. Okay, now the point where these inhibitors will react with the active site of this enzyme, okay, when these inhibitors combine with this active site of this enzyme, they will not make this substrate to be able to react with the enzyme. I need you guys to just follow me very carefully because this might be a very tricky part. Now if these enzymes are combined with these inhibitors at this spot, the substrate cannot react again, so there will be like a competition. Okay, no reaction can take place. You agree? Because this spot has been blocked, where this is supposed to lock in with this has been blocked, so no reaction is going to be taking place. So that's what we call competitive inhibition. It's preventing the reaction from happening. Okay, now what will happen is that instead of combining with the substrate, I'll be having something like this, E plus I, giving me EI. Okay, now rather than KM that I have here, I'll be having KI. Okay, now these are both constants normally, and we all know about that. Now normally I have that V is equals to K2ES. We've derived this earlier on in our Martinez equation. Now do not forget earlier on that I said that ES is equals to ES over Kn. Now this was the reason why I said we need to be very careful. I derived out Michaelis-Martinez equation in order for us to get back here and not get confused. Earlier on I'd already derived this equation. If you go back and check your Michaelis-Martinez derivation, the video made on that, you understand the concept behind this. So I can see here that Km is equals to ES, okay, over ES. Okay, now this is settled. Okay, now if I'm dealing with Ki now, you agree with me that Ki will be equals to EI, okay, over Ki. Same thing will go on for EI, sorry, over EI, sorry. Now if it was EI I was also looking for, I'll be having something like EI is equals to E then I over Ki. It's almost like the same thing, Sha. It's just that you are substituting wherever you see S you put I. Okay, now in this case normally we know that E naught is equals to E plus ES. We did that in our derivation also, but now your E naught, that's total E, will be equals to E naught plus E I, okay, Why am I having plus EI? Do not forget, rather than for us to have E plus ES like we used to have normally, in this case it will now be E plus EI. Okay, now E plus EI plus I have ES. All right, now this is enzyme plus, normally I should have just enzyme plus ES, but now I have an inhibitor reacting with the enzyme also, so I have plus EI, so that's the total enzyme involved in this reaction. Okay, now I want us to be very careful about something. Someone might ask me that, Chibi, you said it's only inhibitor that's going to be reacting with it, why am I adding ES to it? Now there's a reason for that. I'm adding ES because I'm not saying that the enzyme will not combine with the substrate. Now if, for example, now here you agree with me that this could also still join to this part could come to this, but the focus I was focusing on was this active site. Now because this active site of the enzyme will not join with the substrate, that's why the product will not be formed. Okay, this will combine with this to give ES. Enzyme with inhibitor is also occurring at the center here, the active site here, to give EI. Okay, now that means the enzyme is combining with the substrate to give ES, is combining with the inhibitor to give EI. The only different thing here is that the product will not be formed. So it's like these two major things are occurring, but no product can be formed. All right, now I have if that is settled, I can say that my E, okay, E will now be equals to, I already said it earlier that K E naught is equals to E plus blah blah blah, so I can now say that my E naught is equals to, now this place is a little bit tricky, so let's just look at something here. E naught will now be equals to, if I factorize E out, okay, I will have 1 plus, now for EI is EI over KI. If I factorize this E out, okay, if I factorize this E out, I'll be left with I over KI. Okay, I over KI. All right, now plus for the other one, which is the K, the ES, I said it here that ES, if I factorize E out, I will be left with S over KM. Over KM. Okay, now that is settled. I already have the value of my E naught. I can come back here now to say that my ES, now you agree with me that E is equals to E naught over the whole of this, so ES will now be equals to, I'm having E which is now E naught over, I have 1 plus I over KI plus S over KM, okay, dot S. Okay, now this is settled. That's the value of my ES. Now I can further say that V is equals to K2ES. I told you we've established this way earlier, so V can be equals to K2 E naught dot S over, now if I multiply through by Km, this denominator here, if I multiply through by Km, I'll be having Km plus Kmi over Ki plus S. It's nothing complex. We are still doing the same thing. All I'm doing is just factorizing, finding the LCM, factorizing, multiplying through by. That's the major thing that's changing. So now I can say V is equals to K2 E naught, like we said earlier, is equals to V max, right? We said it in the derivation of Michaelis-Menten equation. Now I can factorize Km here. I have Km into bracket 1 plus I over Ki plus S. Okay, now this becomes, I have V is equals to V max S over, now Normally it should be km plus s, but this km now have an approximated value, so I'll be having km approximated plus s. Now I'm going to explain the concept of this approximated value. If you draw a graph, for example, let's say a graph of okay, normally I'm going to use, let me use line weaver buck plots, 1 over v against 1 over s, okay, and my intercept is 1 over v max, like we all know. Now normally this is what I should have, okay, normally this is what I should have if I have no inhibitor. Now by the time you add some inhibitor to it, you notice that your plot will change to this direction. This is from studies, that's from what scientists noticed if you have some inhibitor. Now by the time you have more inhibitor, that you have a lot of inhibitor in this reaction system, you'll be having this. So I'm going to call this 1, I'm going to call this 2, and I'm going to call this 3. Now this 1, this 2, when I have more inhibitor being added as 3, you notice that the slope is what is changing, the intercept remains the same. The slope is changing and the intercept remains the same. Now from the line weaver buck plot, it is 1 over v is equals to, from what we found out earlier, 1 over v is equals to, I think it should be v max, okay, I'll be having 1 over v max, all right, plus km over v max s. Now let's look at this thing. If I'm saying that the intercept is remaining the same, I think this makes sense because the intercept is actually not changing. All the intercept remains at this spot. Now what is changing is the slope. Now if the slope is changing, the slope is equals to km over v max. Am I right now? Okay, now if the slope is km over v max and I'm saying that this is remaining constant but this is changing, that means what is changing is km. So there's an increase in km. Look at the slope is increasing as you're adding the inhibitor, so that means that I have v max constant and I have km changing. Now if you look at what we've derived very carefully, it makes a lot of sense. V is equals to v max s, which is the same thing as my Michaelis-Mentinis derivation. Now the only thing that is changing is km. I have km times something. Now this km times something will give you km approximated value, okay. Now this means that something has been added to km. When you multiply something by another thing, obviously means there's an increase of some sort, okay. Now in this case, now I have my km to be increasing, which means my slope will also be simultaneously increasing. So rather than km here, I'll be having km approximated with the inhibition applied. That's just the basic concept of competitive inhibition. So once you can understand what is supposed to happen, then that's all. Now the reason why I told you that km is affinity of the substrate, of the enzyme for the substrate, that how much does this enzyme actually want the substrate. Now normally if you can add more inhibitor, you notice that the enzyme will be having lower affinity for the substrate, okay. That as km is increasing, the enzyme will be having lower affinity for the substrate, which makes sense. As I'm adding more inhibitor, the enzyme will not want so much of the substrate because the inhibitor is already too much on the enzyme. But by the wayside, the major concept is just for you to understand what the slope should look like, because you might be asked to sketch the graph, or you might be given a graph and you might be asked to interpret. You might be given a graph with no inhibitor and some inhibitor. You might be asked to interpret. When you're asked to interpret, what you're supposed to do is to explain the reason why, and this is because of the km approximated value, and as km is increasing, the slope is increasing. That's all. I hope you guys really understood what I explained. If you have any question, contact me. Bye.